Tonight's homework is on showing trends in data through the use of scatter plots. But before we start that, there are a couple things that need to be reiterated about graphs in general that you will need to use this year. The first thing is the axes. The one that goes straight up and down is the y-axis. Y to the sky, if it helps you remember it. The one that cuts across is the x-axis. Even though it's not relevant in this graph, it's important to remember that the x-axis continues to the left to show all negative x values and continues down below on the y to show all y values that are negative. The point 0, 0, which is circled in green, is also known as the origin or the beginning. It's the point 0, 0 written written in XY order 0, 0. So x is 0, y is 0. It's important to remember that is the origin. Also important to remember is that data and scale and intervals must be consistently represented. For example, on the x-axis, you can see that there is a gap of 1, 2, 3, 4, 5 intervals between 50 and 100. Therefore, that distance of 50 divided by 5 means that each interval there is an interval of 10. It's really important to keep a consistent interval everywhere, or you'll be have a misleading graph and your data won't be fairly represented. Also noteworthy is that the y-axis has an interval of 1. That's different, of course, from the x-axis with a scale of 10, but is completely fine so long as each interval on the y-axis has a consistent interval of 1, a uniform interval, 1, 1, 1, all the way across. It's also important to note that if we had a line that proceeded up vertically or through the diagonal points on this graph, this would not be a slope of 1, because as you move 1 to the right, you would have moved over 10, and as you moved 1 up, you would have increased 1. So technically, this would be a slope of 1/10, even though if you looked at only the intervals and the lines, it looks like the slope of 1. So in summary, it's y to the sky, x is the one that cuts across. When you list points, they are listed x, y. X coordinate first, y coordinate second. This point right here would be the point 51 over 50 and up 1. All intervals need to be the same. It's okay to have a different scale on the x-axis than on the y-axis. It's also important to note that the units and the category of units are listed. This graph, for example, on the y-axis has the charge, in other words, the money would be the general category, but the unit itself is measured in dollars. On the x-axis, the category would be distance. The unit that they're using, however, is miles. So you want preferably both the category and the specific unit so that when you do a slope calculation, you will have the right blend of units. In this case, dollars on the y per mile on the x. So it's y per x. As you move from the left to the right, you can figure out the increase in dollars per mile. The first category we're going to be looking at is just the general trend. This would be a positive trend. You can think of it as a positive thing because let's say if you had some money, it would be a positive event. In other words, a good event that as time went by, if your money rose. That's one way to remember it. Another way to remember is that if the y is increasing, the y values in general as you move left to right are positive. And the x values are also positive. Therefore, this is like a positive divided by a positive, which of course is a positive value. The slope will be positive, and this is a positive trend. Okay, this shows the full XY axis or XY coordinate grid, and you might have another positive slope even though data could be down here in the negative area. But if you notice, as you move to the right, the points in general on the y are increasing. So this too would be positive, positive slope, a positive correlation. This, as a reminder, is quadrant 1. It's where x is positive. Any point over here is an x value. And where y is positive. Any point in here will be a positive x and a positive y. This is quadrant 2. On this section, any x value, left and right, is going to be negative. But it's still up high here, so the y values over here will be positive. For example, negative 4, 1 is negative on x because you move to the left, and then up 1, positive on y. Over here, this is quadrant 3. In quadrant 3, everything is negative. You're to the left on x, you're down below on y, so it's going to be a negative, negative. For example, this would be negative 5, negative 2, right here. And over here, your x values are positive in quadrant 4, but you're down on the y, so you're down in the negative zone on the y. This point right here would be positive 2, you move to the right 2, and down 4, so that's 2, negative 4. So a negative trend would be any set of data that, in general, as you move from left to right, the values in general might be falling over time if you were to draw a line that sort of averaged all the points together. You don't have to hit any one point, but you want to stay as close as you can to all the points to give the general sense of which way the data is trending. Okay, so for your first piece of homework, you're going to create a graph which will show the gas remaining in your gas tank in gallons over time in hours. Time, for our purposes, is always going to be independent. It will always be on x. The gas, therefore, will be dependent upon time. It's going to be on y. And you'll make a scatter plot for 2 or 3 different cars showing what's happening to the gas that is remaining in those tanks over time that you drive in hours. Be sure to label all axes and have even intervals on each axis. Okay, so for your second graph, you're going to make a scatter plot. This again is all imaginary, but it should be based on what you would imagine what would happen to your rate of typing as you practice typing each day for a week. So on the y-axis, this is a rate, words per minute, a rate in words per minute, and on the x-axis is time. For one more graph about practice, this is going to be the time it takes in seconds to run a 400-meter race over the course of a track season. Just so you know, the world record is probably around 45 seconds. A really good high school time is around 60 seconds. And lastly, the amount of calories in your daily diet and the average, how it affects the average length of time you spend waiting at stoplights each day. Go ahead, use your imagination. This might be something slightly different from positive, negative, or 0.